Okay, so as I was saying that let's first clear up the two complete different indexes so that you remember how it's being categorized. The first one is electromagnetic devices. The missiles that are controlled by electromagnetic devices, they can be control guidance missiles and homing guidance missiles. However, the other method can incorporate electromechanical devices, and there are again two categories, but we'll be studying about only one, that is self-contained guidance system. Okay, coming up to control guidance missiles. Now, control guidance missiles can be easily, before I start with the slide, I must tell you that it's basically controlling a helicopter or a small remote control car with your wireless remote. It's very similar to that. However, the control station is too big to be, uh, you know, created and generated and then connection to be made with the missile, but the working is very same. However, it's a very long range. It can be connected. The two different radars, a transmitter and receiver, can connect up to 5,000 kilometers. Okay. Now, talking about that particular thing in terms of definition. So, control guidance missiles are the missiles which are guided on basis of the electromagnetic radiation. That is the EM radiations. Just like your radar connects up with another radar, or your TV remote connects up with your TV, that is basically infrared. So that kind of control is called control guided missiles. Now, this is basically dependent on radio control or radar control between a point that we call it as ground station, and there can be multiple ground stations connecting up or giving commands to a single missile, and the other point is on the missile itself. Using the guidance information that is being transmitted from ground station to the missile, there can be several data that can be fed that will see. And from ground only, using just like you control your helicopter with a joystick, you can control your missile with a joystick and with certain different commands and buttons that are specially provided to keep the missile on the targeted course and hit the target with maximum amount of accuracy. Now, within control guidance system, there are two different categories. Again, the first one is radar control guidance, or we also called it that command control guidance, where all the instructions and commands for the missile, like how it has to go, what location it has to cover, what direction it has to follow at what particular time. Thus, all the commands or instructions are given from outside the missile. Now, yeah, yeah. Okay, now the guidance system of the missile has a receiver. Obviously, the missile has a receiver and the ground station has a transmitter. So you transmit the data from ground to that particular missile. Okay, now the receiver can receive data from ship also, from ground station or from aircraft, no matter from where. The ground station has to be set up somewhere apart or somewhere external of the missile. Now, talking about the missile flight path control system. Now, missile flight path control system is a special system that is incorporated into the missile. Now, what it does actually, the flight path control system, when you give a command, let's say you give the command to your joystick that you move your joystick to the front side. So it converts the amount of or the degree of the joystick movement in the front direction to the actual maneuver of the missile. Okay, let's say with your joystick you move it 20-degree left. So what your joystick 20-degree means to the missile, that conversion is done by the flight path control system that is given into the or fitted into the missile. And these different guidance systems are fed to the attitude control system. And as they've already explained, what are the three different attitudes? They can be roll, pitch, and yaw. So this is very similar to controlling your missile with a remote control. Okay. Now, in this method, one or two different radars are used to track missile and target. Track missile and target. How? Why we are saying this? Let's say I'm giving you a complete scenario so that you can imagine it in a better way. You're sitting on the ground somewhere at the ground station, okay, and you have two different radars. With one radar, you are tracking your own missile that we'll call as friendly missile, okay. The second one, the second radar is detecting for any target within the range of the radar or within the range of our territory, okay, and it is only searching for the enemy radar. Now, the other radar tells the control station that there has been a target, there has been an enemy missile detected within the range. Now this kind of data is given from the other radar. Okay, now that data will be taken. What data? How much high the enemy missile is flying, and what is the distance of enemy missile from the ground station. These two things that we actually call as azimuth and elevation. In terms of aerospace technology, those two terminologies, the height is called elevation, and the direction, the direction in terms of reference to a particular north, that is called as the azimuth. So the azimuth and the elevation are fed from that particular radar which has detected the enemy to the ground station, first thing. Now this, on basis of this particular direction, the control operator or the person who is in operation, he controls the missile so that our friendly missile can go and hit the enemy missile actually. Okay, this can be on various methods. There can be a separate control system that can be given on the missile as well, but we'll talk about that later. Okay, so I'll read out the second para because it's actually states the scenario I was explaining. As soon as radar is locked on to the target, the tracking info means for the enemy missile, the tracking info is fed into the missile. Missile means our missile, and then the missile is launched and tracked by the radar throughout the time, and targets elevation and bearing, the azimuth, are continuously fed to the missile computer. Okay, so whatever controls you are giving through your joystick, that particular thing goes to the missile computer, and they are changed accordingly for the particular maneuvers, like how much your joystick movement means to the fin movement or grid fin movement or thruster thrust. These kind of conversions are done by a onboard missile computer. Now, this particular information is analyzed and the missile intercept flight path is computed all on ground only. Let's say, I give you an example, because why I'm explaining this first category importantly is because you understand one category and there's certain small modifications in all different categories, and you'll be able to understand all of them in a very quick way. Okay, this particular thing we'll talk about. I tell you that whatever direction you're sitting, okay, let's say you're facing to the north. Assume that you're facing to the north. Okay, now from your north, at north 30-degree, there's a target seen at a height of let's take a height, let's say 1,000 meter, and at a distance of 1.5 kilometers. Okay, again I'll repeat, at an elevation of 1,000 meters, at a distance of 1.5 kilometer, and the bearing or the angle, the azimuth angle, is north 30-degree. Okay, 30-degree north. Now these three data are given from the radar that a target has been seen at this position. Okay, however, the target is not still in the space, not still in the sky, but just taking an example for a fixed target. Okay, because locking mechanism is quite different from the scope of this seminar, that we'll talk some other time. Okay, now this particular data has been received from the radar that is tracking the enemy missile. Now this will be read by our computer on the ground station. Okay, that okay, a target is at this much of angle, bearing, and distance. Therefore, if and my missile, the other radar is detecting our missile's location. Now you have your missile's location and enemy missile's location. Now the the ground station computer will compute the exact maneuvers. Maneuvers means change in direction, change in height. Okay, it will compute the exact change in maneuvers. Okay, so that if that maneuver is fed to your own missile, it will eventually go and collide with the enemy missile. Okay, and the intercept will be done. Now, this is how the radar control guidance, okay? We are talking about the radar control guidance. So this is how radar control guidance or command control guidance happens, okay? Now, the only thing is your missile has a receiver, okay? And on ground, you're sitting with two radars, one tracking your enemy missile, one tracking your friendly missile, and you have an onboard computer that compares the location of both your and enemy missile and computes a particular maneuver. If you do that particular maneuver sitting on the ground, you will eventually hit the enemy missile and you will collide with it, and you might complete the mission. Okay, this is how the radar control guidance method looks. Okay, the aircraft that is circled up, that is blocked in red area, is the enemy aircraft on the top right corner. On the top left corner, the one fitted into the green rectangle is our missile. Okay. Now, and on the ground, as you can see, this is just a control panel. This is not the complete ground station. This is just a panel of your ground station control, and this is the exact panel, by the way. This is not something copied or taken from somewhere or PS4. Okay. Now on the control panel in the ground, if you see, and along with that, this must be noted, it's not just a control panel, it's a control panel, and it also has a computer that computes the exact maneuver, what maneuver should be done. Okay. And this can be fitted on a ground station, submarine, ship, aircraft, anywhere. Okay. If on that control panel, if you look onto the right side, there's a small joystick. If you look onto the left side, the 3 buttons that are for different phase boosters. Okay. And there are separate different controls that we won't be talking about. We just care about these two. Okay. Now what happens, and along with that, there are 2 radars. Okay. 2 radars, one tracking the enemy. So when the enemy is tracked, actually, okay, the enemy location is fed. Okay, the enemy location is taken on the onboard computer. On that basis, okay, on that particular basis, it sends and along with that, one location is coming from our missile. One radar tracked the enemy aircraft. One radar is tracking our own missile. Now both the locations are with us. Okay. On that basis, the computer computes a particular maneuver or particular location where the intercept is possible if we move our missile to that particular direction. Okay. And that particular maneuver is fed from your joystick and different launch controls to your missile this way. Okay. So that your missile can hit the enemy aircraft and save the territory. Okay. Now this was radar control guidance. Coming to beam rider method. Okay. Now there is nothing much change. Okay. There's no much change. The only thing is, instead of a computer on ground, okay, a computer is fitted into the missile itself. All you need to do is whatever position you are getting from the enemy, whatever location of the enemy you have detected, do not compute any maneuvering changes. You just send that data to your missile. That's it. So once you send that enemy data to missile, the missile will itself compute a path, itself find up a maneuver that must be done to go and hit the system. So this is a kind of intelligent missile, and this particular method is called as beam rider method. So I'll read out the second paragraph because that's what I was talking about. Instead of sending computed interception maneuver to our missile, okay, from the ground station on basis of enemy location, in this method, enemy's location is directly sent to the missile. Okay, there's no ground station in between. I mean, it is there just to capture the data and send it, no computation. And further, the missile itself computes the interception maneuvers and performs the maneuver accordingly so that the interception can happen. Okay. Now, the missile is designed in such a way so that it can formulate its own correction signal. Okay. Whatever position of the enemy you have given, on that basis, it will compute that, okay, if I follow this particular position, I'll go and hit the target missile. Okay. Now, missile flight path is sensitive to any kind of deviation, right? Okay. So what happens? What are the advantage of this particular beam rider method? That it requires only one radar. Okay. You don't have to take data from the missiles. I'll go again to this one. How many lines do you see over here? There are 3 communication lines, 1 red, 2 blue, right? Because first you need to take data from the enemy and then take data from our missile and compute both of them and send again data to the our missile. Okay. Why? Because there's a computing system on the ground. Okay. Now, if you look here, if you look to the beam rider method, okay, you'll find only two communications. Okay. So for 2 communications, there's only 1 radar required. So it reduces the number of radar. Okay. And along with that, since the missile is formulating its own directional commands, there's no ground station in between. Okay. Several missiles can ride the same beam. How? Let's say if there's a swarm of missiles, or if there are multiple missiles and the target is too big, so I'll send the same enemy location to all the missiles and they'll formulate their own path so that they eventually go and hit or collide with the target. Okay. So these are the 2 advantages of this method. What happens? We take the data from the enemy. Okay. We do not compute because there's no joystick, as you can see. There's no joystick. Sorry, the joystick has been mentioned, but there's no joystick over here. There's only, you can launch it and just look what's happening. Okay, and this kind of missiles are also called as fire and forget. Okay, so once you take the enemy data and then you feed it to our missile, that's it. The missile itself computes. There's no computational system on ground. Okay, so the missile computes its own path and maneuver so that it can go and hit the target. Coming up to the homing guidance missile. Okay. Now in homing guidance missiles, if you remember the index again, I'll come to the index again. Okay, so we had two categories. In control, we have two. One is radar or command control guidance. The other one was beam rider method. That was inside control guidance missile. Now we'll come into homing guidance missiles. Okay, now coming up to the homing guidance missiles. Okay, now this is homing guidance missile. Now, what basically it means, why homing, and what's different from control guidance missiles? Homing guidance missiles, they are basically systems that also detect the location of enemy on their own only. Till now, what we did, we were taking the location from ground station of the enemy, right? And then in the second, and computed it on ground, and then in the second one we computed it inside the missile only, but the location was anyhow taken through a radar on the ground station only. Okay, now there's an involvement of ground station. In homing guidance missile, basically there's no involvement of ground station, active involvement I mean, but there is always a manual override button in all of the missiles in the world. Okay, nothing is left on its own. Okay, that was a different fact. Now, homing guidance missiles, they have certain kind of sensors, okay, or a certain kind of device that can detect a special feature, okay, and these special features can be a radio frequency that is being emitted from the target. It can be infrared or reflected laser or sound coming out of a target device, or it can be visual. Your own missile can visibly see the enemy missile. Okay, there can be multiple things. Now, I'll give you an example. Uh, you would have seen like the cases where you fire a missile, you would have seen dogfight, not the street dogs. I mean the fight between two fighter jets, that is called as dogfight. So in a dogfight, the aircraft at the behind, the aircraft which is following up or chasing up the enemy, fires a missile, that is air to air missile or anti-aircraft missile. It fires up that missile. Now, even if the enemy moves to the left, right, up or down, the missile chases it. Okay, it doesn't go straight; it chases it, and wherever it till where it can chase, unless there's a very sharp maneuver, it goes till that spot and then hits it. Okay. Now, how the missile is chasing? How the missile is chasing the particular enemy missile? How is that happening? Now, what is there? There's a very simple theory. I mean, the process of building is too difficult, but the theory is too simple. How? The theory is simple because there's a small thermal camera in the front of the anti-aircraft missile. And what basically it does, it detects any kind of high temperature. Okay. The whole sky will be so cool. The only part that will be will be at a very high temperature will be the exhaust nozzle of the front aircraft. Okay, because the aircraft we are chasing will have its engine at the back, and the flames will be coming out, the hot air will be coming out, and that particular area will be much hotter than rest of the environment, right? So since it's much hotter, there's a thermal camera incorporated in front of the anti-aircraft missile launched from the uh, aircraft at the backside. Okay, so what basically happens, it's searching, it just searches wherever there's a high temperature, it moves to the high temperature direction. So no matter where the enemy missile is moving, it will keep on chasing its engine, and whenever it finds or gets into the range, it hits it. Okay, so this is a special feature. What's the special feature? The heat is the special feature. Okay, so homing missiles detect a special feature in the enemy. Okay, now there are two parameters that must be known that I was talking about since the start. One is the azimuth, the bearing angle, and the elevation. Okay, now how the tracking is performed? Tracking is performed with a movable seeker antenna or an array, a different antenna. We'll talk about this. The first one is active homing missiles. Okay, now active homing missiles are the missiles in which both the transmitter, I mean the one which sense the pulses, that is also inside the missile, and the receiver is also in the missile. Okay, you would have seen ultrasonic distance sensors. Okay, the ultrasonic distance, you would have seen those small robots which travel towards the one side, and as soon as they see a wall, they turn back. So what's basically doing? They're sending ultrasonic waves, and as soon the timing between the transmission and then reflection and returning back is too less, it seems that there's an object so near to the robot, so it turns to a certain direction. Okay, so that particular thing, one is transmitter, the other one is receiver. So the weapon itself has both the transmitter and receiver. There is no separate sensing or transmission or receiving from the ground. Okay, now search or tracking is conducted by any tracking sensors, because there can be more than one tracking sensor, because we don't know what kind of missile we are going to face. Okay, it might be soundproof, so we might need a thermal camera, or it might be thermal proof, it might be running on a turbofan engine, therefore we need a uh, television camera to detect it with the visuals. Anything is possible. So more than one sensors are incorporated into a single missile. Okay, now target is tracked in a monostatic geometry. Okay, why monostatic geometry? It's not just seeing in the front direction, it's not just where the camera can see. The camera is movable from one point to another point, not completely 360-degree, but mostly 120-degree or 135-degree. So basically it's looking for a long range that we call as the monostatic geometry. Okay, now since the transmitter is on the missile, the receiver is also on the missile. So both the detection and both the sending of data is from on the missile itself. The onboard computer is also inside the missile only. Okay, so let's say there's a thermal camera into the missile. So the thermal camera sees where the target is, or where the elevation, high temperature is, and that particular data is being fed. An onboard computer detects that, okay, in my camera frame, in the thermal camera frame, the high range of temperature is on the top left corner. Therefore, I must move to that side because that can be the target. So the complete detection, complete command, and complete control is within the missile only. Those are called as the active homing missiles. Coming up to the semi-active homing missile. So everything is same. Okay. Now in semi-active homing missile, instead of detecting or instead of a sensor, okay, in the missile only, we put a sensor on the ground. So there's a special radar on the ground which is tracking for enemy. As soon as it sees the enemy, it transfers the the missile is equipped with a radar receiver. Okay, and there's no transmitter. There's no transmitter at all. Okay, so what basically happens, from a ground station, a ray is transmitted throughout the space. Okay, and wherever it hits the enemy, okay, whatever point it hits the enemy, it reflects back and goes to the missile. We'll see a picture of it so that it becomes more clear. It goes to the missile, and the missile is able to detect all the data that's coming through the enemy missile, and on that basis it detects, again, the onboard computer is on the missile only, so a maneuver path is computed. Okay, but there's a special advantage over here. Let's say the target is too small, because you might have heard, the airport security becomes too tight if there is a case of unpredictable or un what we say, something that's too small to be seen. I'm not getting that particular word. Something too small to be seen, that kind of drones might be on the airport within the range, and that might damage the aircraft. So at that particular time, the detection systems become too what we say, too fuzzy, because it's not able to detect very small objects. Okay, but in case of this semi-active homing missile, since the radar is on the ground station, we can adjust the frequency, wavelength, and the power of the signal that is detecting. Therefore, the smallest of the smallest enemies can be detected. Okay, so this is a good advantage of the semi-active homing missile. Now, how does it look? We will see. Okay, now on the left side, it's our missile. On the right side, it's enemy aircraft. Okay, so there's a ray being transmitted. Okay, I mean, just like ultrasonic distance sensor. So a wave is sent, and then it's being reflected back. Okay, the reflected ray contains the data like position, azimuth, elevation. Okay, how much far the enemy aircraft is, or what direction is it flying. These kind of data, and on basis of that, there's an onboard computer on the missile only that computes that. Okay, on basis of this position, azimuth, and elevation, it computes a maneuver so that it eventually hits with the enemy aircraft if follow that maneuver. These are the active homing missiles. Now talking about the semi-active homing missiles. So as I said, there's a ground station that sends the transmitted ray to the aircraft, which reflects back to the missile. So what happens? First, a ray is being transmitted onto the enemy aircraft, which is reflected to the our missile. Okay, and that contains position, azimuth, and elevation of the enemy, and on that basis, the onboard computer detects the maneuvers. Coming up to the passive homing missiles, the third one. Now, passive homing missiles, it only basically depends on target as a source of tracking energy, or we can say, I mean, that's also a disadvantage that unless the enemy wants to find it, okay, unless the enemy is desirable that uh, we must find it, we cannot find it. Okay, how? Uh, it's basically on the radiations or heat that is dissipated by the ship, submarine, aircraft, engine exhaust that I gave the example of in the starting. Okay, in the case of a dogfight. So let's say the aircraft that is in the front, the enemy aircraft, it doesn't run on a jet engine. It runs on propellers. Okay, so the overall temperature is going to be very same to the external environment, right? So there's no temperature change. There's no thermal variation in the complete frame of the thermal camera. Okay, so how are you going to detect it? So there's no use of using passive homing missiles in these cases. Therefore, unless the enemy wants it wants you to find it, okay, there's no way you can detect it. So therefore, it depends on the source of the tracking energy. Coming up to retransmission homing or track via missile, this is a peculiar concept, by the way. How? That we'll see. It's a blend. It's a mixture of radar control guidance method and semi-active homing guidance method. In case you haven't forgotten what we were talking about, the what was first of all, we'll talk what is the radar guidance. Okay, or we'll first talk about the semi-active homing guidance. In semi-active homing guidance, the missile contains a semi-active seeker. Remember that semi-active homing, a ground station transmits the ray or transmits the particular radiation, and it goes to the enemy and reflects back. Remember that? Therefore, semi-active seeker determines the azimuth and elevation from missile to the target through illumination from launch site. I mean, reflection back. Okay, that is the semi-active homing guidance. And then whatever the data is received by the missile, okay, that is transmitted to the launch point. Okay, now launch point has got a control panel or a computer for computation of the data that converts whatever data has came from missile, converts it back to the required maneuver, and then sends it back again to our home missile. Okay, how it is? First of all, we see the passive homing. There is no radiation sent. There's only if your enemy is going to help you out willingly or unwillingly, then only you can find him. Okay, so what happens is only one ray that is reflected from enemy to the not reflected, that is being sent from enemy to our missile. Okay, and that can be electromagnetic wave, thermal radiation, or visible picture, or these kind of data. Now coming up to the retransmission homing. Now look at that carefully. So what happens? First of all, a ray is being sent, okay, from the enemy to our missile, and then from our missile a ray is being transmitted to the ground station. Okay, you're getting me? The missile detects the enemy. First of all, the missile itself, there's no, the radar is in the missile only. So missile detects the enemy and then sends that particular data, whatever is received, without calculating. There's no onboard computer on that missile. Therefore, whatever data we have got, it sends it to the ground station. Okay, the ground station computes the maneuver details according to the angles given by missile and sends it back. Okay, as you can see there, yellow transmission, red transmission, and green transmission. Okay, now since the missile is itself tracking the enemy, that's why we call it as track via missile or retransmission homing guidance method. So these are the 4 different guidance methods of what? Of the electromagnetic devices, man-made electromagnetic devices. Okay, now coming to the electromechanical devices, second one, that is self-contained missile. Okay, this is a very short description. Okay, now in self-contained missiles, all the guidance and control equipment are within the missile only. You cannot control it from ground. Okay, there is no control from the ground. There's no radar on ground, nothing. Okay, everything is within missile only. Okay, now basically used for surface to surface missiles. Okay, and they cannot be jammed since there is no communication happening from ground to missile or missile to missile. Therefore, you cannot jam the signal. It's like uh, self-talking missile kind of. Okay, so you cannot interrupt the talk from a missile to ground station or from missile to missile. Now it has got four different categories. The first one is preset, the second one is terrestrial, the third one is inertial, and the fourth one is celestial. So we'll differentiate between all of them. In preset guidance missiles, this is very simple, as you can understand with the name itself. Preset guidance means you set the location. Okay, just like you set the GPS location into a Tesla car and you are able to reach that location. Similarly, you feed the particular location, that is presetting, and your missile launches and goes to that particular location. Okay, now before the missile is launched, all the information is already fed into the missile and it's launched. It is only useful when the stationary targets, first of all, there should be stationary target. If the target is moving, you cannot give a particular GPS location of the target, because now it's at this point, now it may go to that point and then that point and so on, right? And along with that, it is basically for a large size. Okay, it cannot go and hit a specific person. It can go and hit a particular territory, a particular big area, aircraft hangar or an airfield. Okay, the major advantage is it's very simple, as you can understand. You just have to feed the location and it goes from one point to another point. Okay, and requires no tracking or visibility, so there can be no communication error or no such kind of interruption of the data. Coming up, inertial guidance is very similar to systems where stabilization is required. Now, this accelerometer, the gyroscope, is incorporated into inertial guidance missiles. And what basically a gyrostabilized accelerometer is, it tells in what direction is your body being tilted. So let's say my body is tilting to the left direction. It will tell that your body has tilted by 40 degrees in the left direction. And similarly in all the directions, X, Y, and Z. Okay. Now a particular, this is basically used for the intermediate push. Like if this is not a particular guidance system, this cannot be used in the complete missile system. Okay, this is basically used to maintain the course. Okay, how? Let's say your missile is moving from this location, point 1 to point 2. Now in between there is a wind, there's breeze coming up, there might be hurricanes, and there might be several kind of things. There can be thermal radiations, thermal currents, multiple things that might be misguiding the missile from its original course. So your accelerometer keeps on detecting any kind of change in the course, whether the missile has tilted to left, right, up, down, or has rolled on its axis by even a degree. It detects it, and the detection, after detection, it re-maintains it or maintains it or recalibrates it to its original position. So there is no change in the original course of the missile. Coming up to the celestial or stellar guidance, uh, I don't know how many of you know, if you buy a costly telescope, not up to 10,000 and 15, might be some 45, 35,000 telescope, there's a star tracking system into it. Okay, so if you feed that you want to see the polar star, the telescope will orient itself to the polar star. So there are multiple star trackers that can orient themselves into the direction of the star. So such kind of star tracker is incorporated into the missile, okay, which is used for the reference. So let's say my pole star or the polar star is taken as the reference axis. Okay, so a star tracker will keep a track and will keep its eye onto the polar, star. Okay, and accordingly it will tell that okay, this is my reference point, and on basis of that, the complete environmental axis is being calculated. Okay, now it's highly desirable because it can be used for long range. As like you go anywhere on Earth within the same hemisphere, you will be able to see the star. Okay, and the horizontal or vertical reference to Earth, and a star tracker, and along with that a time base, because you must know the time differences, because the Earth is continuously rotating. Therefore, you must know the time, how much time has elapsed, and accordingly, we must have a navigational star table as well, which star will be seen at what particular time, which should be chosen as a reference. But there's a problem. The missile must fly above the clouds, okay, so that it can see the star actually. Coming up to terrestrial guidance method. Terrestrial guidance method is straight through. Okay, it's all about the terrain contour matching. If you might have attended our image processing session, you would be more clear about it. Completely, the coordinates are coming from visual. There's a small camera that is able to detect the target. Okay, a particular contour is being set to match. Okay, and on that basis of matching the terrain contour, okay, on that whether the template is matching from the real-time image, it detects, okay, this is my location or this is my target, or am I flying at the right location? Okay, so this kind of matching by visuals is called as terrestrial guidance. And this particular whole method is called as DSMAC, or digitized scene matching area correlator. Okay, so the missile can correct its path on the basis of, is the image matching with the whatever is pre-feeded data. Okay, like if I feed my picture into the missile will be able to launch, find me, chase me, and then hit me up. Okay, so this is the DSMAC technology that we also called as the terrestrial guidance system. Okay, now with DSMAC system, we cannot deliver the conventional medium explosives because the accuracy is not that good. Okay, so probably it's used for the nuclear warheads. It has never been used, but it's probably used for nuclear warheads, so that even the target is missed, the detonation area will be so large so that it can actually or eventually destruct the target. Okay, TERMAC and DSMAC requires uploading and editing because data will the preset data of the location and the target will have to be fed into the system that requires trained and talented personnel. So simply untrained person can't do that and requires a lot of costing. And that's how TERCON looks. Okay, so on the top right side, if you see, there's a small image. The missile will be detecting for that image within the whole contour because there's a small television camera. And what will happen, it will keep on detecting this light. And as soon as it sees that the area looks very similar to the picture that is already fed into my system, it will get to know, okay, I'm at the right place, or okay, I have seen the target, either of them. And that's how the TERCOM works. And with this, I would like to end the session and thank all of you and Goa State Innovation Council as well. Devashish, are you hearing? Okay. Anyone has questions?